Hey everyone, probably Thomas has already given us some context on what we will be doing today. So before we can start, I have some couple of questions. So how many of you have used Google ADK? Google ADK? Okay, some of you. How many of you know a concept about agents? Have you used any libraries before? Like LangGraph or anything? It can be LangGraph, Agno, Llama Index. Have you heard of these names before? LangChain at least? All right. How many of you know a concept of vector search? All right. So what we'll be doing today is we'll be talking about agents and how you can give long-term memory for your agentic workflows. There is also some edge cases that we need to tackle, right? Let's suppose when we talk about memory, people only think memory as, okay, we retrieve something and give it to the agent, right? And there is a lot of the concept that goes behind in retrieving these details, right? So we'll be talking about certain edge cases and how we can solve it using a demo where we'll be using an open source library, right? A quick intro about myself. I work as a founding engineer at a research lab called Kaivid. And apart from that, I've been part of Google Developer Experts program for last 3.5 years now. And I love contributing to open source. I've been part of Google Summer of Code for 2 consecutive years. So 2024, I was part of Red Labs organization. And in 23, I was part of CA Microscope. And apart from that, I'm also an ambassador for Quadrant, which is a vector search engine. So now let's talk about context, right? So when we talk about context, every one of us are using LLMs, right? Now, when we use LLMs, we only give certain information and then we get the results out. And just using prompt, it's not complete engineering, right? So when we talk about prompts, it's like how do you fetch the knowledge? How do you get the context is very important. So this is where context engineering is very important. Now here, when we talk about context engineering, it's again a way lot image, right? Or a complete different image. So let's talk about context engineering. How do we get the context? Now, if you have your own knowledge space, right? For example, let's suppose you have your company, you have multiple policy documents. And if you want to build a chatbot, you need to have that knowledge base in place. So this is where we have RAG, where you have your knowledge store, save that in a vector DB, and fetch the relevant information. So that is one area. Then you have memory. So let's suppose you have your own preferences, and you want your agent to remember this preference over a longer period of time. It should not just be within one chat window. Even if you create a new chat window, you should still remember what your preferences were. So this is where our main focus for today is, like how do we build this memory component? And then you have again prompt engineering, which is just a string template, input in and input out. And then you have state. So state, it's basically a temporary session. For example, if you have a chat history, now you have 10 messages. So whatever you have chatted earlier, it should be in your context. So context engineering is very important whenever we are interacting with agents or large language models, right? So when we talk about agents, it's only 2 concepts that you need to remember. One is stateless agent and one more is stateful agent. So when I say stateless agent, it is just input in and input out. For example, let's consider I'm traveling to Vienna, recommend some good restaurants to try, right? A simple prompt. So based on this prompt, you have very generic results. And whatever results are there, probably it is famous, you have good reviews, you have better results, you're getting a decent response. But this is very generic. So when we talk about stateless agent, you don't have any context that you're providing. You're just giving your input and you're getting a generic response. What we need instead is very personalized response to our own needs. Now, if you look at this example, you have user, then you're giving the input to the agent. And one additional thing is you have your context, which is your memory storage. Now, it's again very simple. I have a preference, like whenever I travel, I need vegetarian food, right? So you give your preference and then you're asking the same question. Now, whatever response you have, it is more personalized to your preference. But now the problem statement is, I can't give my preference every single time. Your agent, your large language model needs to remember your preferences so that you don't repeat yourself. So this is where, when we talk about agents, there are tons of things, right? Now, if you have used Google ADK, you might have seen the structure. When you define your agent, the first thing is you have tools, right? If you want anything related to search, you will pick search tool, right? That is the action. If you need anything related to code, you'll use code interpreter. So based on the user requirement, you're picking one tool at a time, which is your action. So we give 10 tools. Now you give your user requirement. Among those 10 tools, only one tool will be picked, which is your action. Now you have tools and action. And next thing is the planning part. Once you get the context, how do you generate the response? Here is where there are tons of research available. I'm not sure if you have heard of few terminologies, so I'll just split it out. How many of you have heard of React? React. I'm not talking about programming language, I'm talking about reasoning and action. Have you heard of this prompt engineering? So basically, let's suppose you ask anything to agent, right? Agent, it is just dump, it will give you some response. But there also has to be a feedback mechanism. For example, you ask a prompt, then it will think, it will take an action, then there is an observation. So thought, action, observation, then again repeat. So there is a feedback loop in between. That is called your React prompting, which is again released by Google. And then you have chain of thoughts. How many of you have heard of chain of thoughts? Have you used DeepSeek before? DeepSeek models? So if you look at DeepSeek models and if you look at the technical blog articles, when you want to train your DeepSeek R model, so you have zero. Once you have zero models, there is tons of data set which is available. Whenever you need reasoning, you use something called as chain of thoughts. In simple terms, chain of thoughts is nothing but step-by-step solution. You analyze, you reason, and then you generate response. So this is mainly used for prompt engineering technique again. And then you have reflection, which is again used for error mechanism. Let's suppose if you've done any mistake, how do you identify that error and fix it? So there you use little bit of critique technique. Critique in the sense, hey, this is how it is supposed to be, and you're supposed to resolve this response. So when we talk about planning, it is just prompt engineering. You get the context from tools, you give it to the agent, you're using these prompt techniques, and then you have your final response. But this is not our main focus. You have planning, you have tools. But our main focus for today is to concentrate on memory. Memory also, there are two types. One is short-term memory and one more is long-term. So as I mentioned earlier, short-term is basically within your same chat. If you are creating a new chat, you should remember those things. Short-term memory will not remember, right? It is state. Second thing is long-term memory. Now, this is our main focus and we'll talk about how to structure this, all right? And one thing what I've seen many developers do the mistake is when you're building a memory component for your agent, you're only using retriever. Now, what do I mean by retriever? You ask a prompt, whichever is the most relevant information, you're getting the context of it. Now, there is a drawback for this. Let's suppose I am asking something related to food and I have my own likes, I have my own dislikes. Over a period of time, if whatever I liked before, now if I'm disliking, you need to have context of both. Hey, you used to like this now in this timestamp and you dislike this at this particular timestamp. So you need to have that relationship in between. This is where most of the open source tools that you see as of now, you have both vector and as well as graph. So it's called hybrid search approach. So here is one movie scene which I'll just relate to knowledge graphs so that you will be able to understand what I'm talking about. And since it is related to Hitler, I have just added this as, short message saying that I have no intention behind what that is about. But it is just a concept which relates to memory palace, right? So I'll quickly play this out.
Oh, it's called a memory. Wait, how did you memorize? And wait, how did you memorize all the names of my nieces and nephews?
Oh, it's called a memory palace. You create a mental room for each person you're trying to remember. And then you think of a shocking image that somehow relates to that person. So, for instance, your niece,
Yeah.
Ava.
Yeah.
I thought of Hitler's girlfriend, Ava Braun. And I picture your niece, Ava, in a Nazi uniform.
Jesus.
I mean, what can I say? It works.
So if you look at this concept, right, you are thinking of a specific image and you're building a relationship for a different object, right? This is where we have knowledge graphs. So in knowledge graphs, basically you have entities. By entities, we mean nodes. So you have Mona Lisa, Da Vinci, then you have Tower Eiffel. All these things are nodes, right? And you can also call nodes as entities. And the second thing is the relationship. How are you connecting one node to a different node? So you have as lived in. So as lived in is basically a relationship on how you are connecting your two entities. Now, why is this very important? When you are giving context to an agent, you need to have that relationship in between. Hey, how is one node related to another node? So once you have this traversal, it becomes very easy for agent to generate better response. So we'll talk about this in detail, but what you need to remember as of now is the vocabularies, which is ontology that we use in knowledge graphs. Second thing is nodes, which is basically your entities. How it is created, we will talk in the demo. Second, third is your relationship. How do you connect one entity to a different entity? So when I say entity, it is basically nodes. So both are same. All right. So now let's talk about little bit technical on how this is actually built and how it is actually structured. So we'll be taking an example of Cognee, which is an open source framework to build your memory layer for AI agents. And the first thing is you need to have your own data, right? It can be in form of CSV, PDF, raw text, anything. So once you have your raw data, the first thing is you're creating chunks and embeddings, right? So you have tons of data, which is in PDF. You create multiple chunks, which is basically your data ingestion. Once you have your data, which is in properly data ingestion pipeline, the next thing is you need to create your knowledge graphs. So in order to create knowledge graphs, we have a function called Cognify, which will create that particular structure. Now in this particular layer, you have your nodes and you have your entities built. So once this is done, the next thing is you memify it. Now, this is an optional step. What do we mean by memify is when you're creating nodes, it is on high level. If you want to create more sub-level to it by adding more nodes, that is where you enhance your platform. So if you don't have enough data, then you don't have to use memify. But if you have very limited data, then you can use it. But again, memify is completely optional. We can see this in the demo. And now add plus Cognify, it is converted to remember. It is just a function when we use Python. And then memify is mainly used as enhance. And then you have search. Once you have your data saved in knowledge graph, you give it to the user. So user can ask their questions. So you ask the question, get the relevant information using search, which is basically recall. All right. So since I said it is a complete data infrastructure, so in this data infrastructure, it can be your any LLMs. So you have Gemini, you have Olama, you have OpenAI, you have Claude. There are tons of LLMs available. And then you also have agent frameworks, for example, LangGraph, Google ADK. If you want to connect this memory layer to any of these agentic frameworks, it will act as a tool, right? So add tool is one, then search is another one, which we will see in the demo. And once this is done, there are three things we have to configure. The first thing is vector database, second is your LLMs, and third is the embedding model. All right. So these are the basic information that how to build your knowledge graphs. But what edge case is it solving? Why do we need this particular approach, right? So I'll talk about two edge cases, which is very important in memory. And even we are facing this particular problem whenever you're chatting with large language models or agent. So the first thing is multi-op reasoning. Now, what does multi-op reasoning mean? Let's suppose you're using any large language models like Gemini. You're not asking only one prompt in a same question. You have two questions in the same prompt. For example, you have X and Y, right? So whenever you're using search engine, you only get information for X, Y is missed out, right? So that search is very important. So what we are trying to do here is first you're creating something called as edge traversal. Here we use a search technique called triplet search. Now what does triplet search mean? Same. You have nodes, you have entities. So you have subject, relation, and object. How do you connect two nodes with the relationship? You're using triplet search to get that information. So I'll show the code logic in the next slide. So major thing is we use edge traversal to get that particular triplets. So once you get the triplets, you're adding that to the context. So if the context is increasing, immediately you use something called as context aggression so that you can compress your context, then give it to the LLM, which is your final layer to generate final response. So you use search, you fit into the context. Once it is in the context, give it to the LLM to generate the final result. So this is the three layers that we typically do whenever we are using multi-op reasoning. And since I said, if you are aware of search techniques, there are different retrievers. One is graph completion, then you have search, then you have temporal, which I'll talk in a minute. Now, here is the first thing. We use triplet search. So what this triplet search will do is, it will give you the nodes, it will give you the entities, and the schema of it. So once you get the schema, you're directly giving it to the brute force where you're getting the context. Once you get the context, you keep on adding it in a variable, then feed it to the large language model, which is your LLM reasoning layer. So the first layer is your triplet search. And second is temporal awareness. As I said earlier, if you are liking something, let's suppose in May, I liked something. Then in July month, the same thing it is disliked. So whatever context you have in the May, it should also use the same information from July. So whatever relationship you are building, it should have certain timestamp. So this is where we have data point. So if you notice in the data point, you have created at and then updated at. So this two acts as your metadata. So once you add this metadata, you have another retriever. So in this retriever, if you notice, you have time from, then time to. So what this will do is whatever preferences have changed over a period of time, you are keeping track of everything. So the first edge case is your multi-op reasoning, and the second edge case is temporal. Now temporal is nothing but over a period of time, if any preferences is changing, just make sure it is in the context. Once it is in the context, then you can give it to your context aggression and then LLM reasoning. So it is just 3 layers. All right. And that's it, the edge cases part. Now what we'll do is we'll focus on demo so that you can see how things works from write your data, then saving it in a knowledge graphs, then using it in a search. So for search, we will be using Streamlit. How many of you have heard of Streamlit? Most of you? So if someone who don't know what Streamlit is, if you build any apps and if you want the UI for it, it is very easy to use Streamlit. And I'll come to the Streamlit part. So as I said, when it comes to Streamlit, there are tons of widgets available. Let's suppose you want to add button in your website, then text, then entry box. All these things, it is just one line of code, right? There are so many apps which are developed by Streamlit, and we will be using Streamlit as well. And this is how the UI looks like, which we'll get to in the demo part. And talking about the code, we'll be using Cognee, so you can quickly check out this particular QR code. And as an alternative resources, you can also check out Microsoft GitHub repository, which is AI agents for beginners. In the 13th chapter, you learn more about Cognee. So how many of you are comfortable with Python? All of you? Cool. Oh, yes. Oh, no, it's an open source tool. So I'm saying alternative resource because you have more information on how to use it. And again, it's configurable. If you want Gemini, you can use Gemini, but this is just a tutorial. It's not a product of Microsoft. And this is the source. If you want to follow along, this is the GitHub repository. You can just search for github.com Lucifer TRJ memory demo. And once that is done, I'll come back to Google ADK on how you can use Cognee as your memory component for your agentic workflows. So let me quickly check this out. So I've created 2 inference files. As I said, there are 3 things we need to configure. One is vector database, large language model, and embeddings. And if you want to use defaults, by default it is OpenAI. So I'll show you the example of default. Then I'll show you the example where you can configure it as well. So starting off with inference, you need to get your preferences. So let me close this. So this is the raw text that I have. As I said, in the flow, first you get your raw data, then you add, then cognify, then memify. So add and cognify as converted to a command called remember. So what am I saying here? Cognee.remember all my preferences. So in this particular step, you are building your knowledge graphs. So in this knowledge graphs, you can also visualize it where you have multiple nodes, which is your entities, and then the relationship. So once you have your particular knowledge graphs in place, I'm saving it in a file, which is basically .html, so that you can visualize it and see how the knowledge graphs looks like. This is where we have completed with the data ingestion pipeline. Once the data is saved in your knowledge graphs, then you can freely use search. So if I check this particular user query, I'll just use cognee.recall, and you can ask any user query as per your choice. Plan a 3-day itinerary for Vienna along with restaurants to try out. Now here what I need is, based on my preferences, it has to draft that particular itinerary, right? So let me quickly show you this particular file, which is knowledge graph. So you have this user. Now, if I click on this user, first I said you create multiple chunks. Let's suppose if I have my data, after data is created, you're doing data ingestion. So in that data ingestion, you're creating chunks. So you can see what chunks it has been created. Once chunks are created, the next step is you use Cognify, which is basically you're building a knowledge graphs. So a knowledge graph, now if you notice, this restaurants is a node, right? Then you have concept, which is again a node. And if I click on restaurants, So if you see vegetarian preference for restaurant, now this is called relationship. So you're connecting restaurants to user, which are two different nodes with a relationship. Now when you're building your context, what it is happening is you're using triplet search. So in triplet search, you will get your subject, you will get your relation, and you will get your object. All these three things is fetched, given to the context, and then you generate your final results. So this is one. Now, if I come back, what you're supposed to do is, I have ENV example. Now, OpenAI by default is your embedding model, and OpenAI itself is your large language model as well, which is defaults. So you just have to say LLM API key and give your OpenAI API key. But what if you want to have your own LLM, which is basically Gemini or different providers? I've also created an example for that, which is custom app. Now here, what we are trying to do is, we are switching our LLM to Gemini. It can be anything from the latest models. If you have followed Google I/O, you have Gemini 3.5 Flash now. Before that, you had Gemini 3.1 Flash. So in this demo, I'm using that particular model. Now it's the same thing again. I'm starting with preferences. Once I start the preferences, the next thing is I want to configure my vector database. So initially it was LansDB by default. Now I'm switching it to Quadrant. So Quadrant will act as my vector DB. So whenever you're using a Quadrant vector database or any vector database, you need to, there are three things that you can do. First thing is you can use their cloud service. Second is you can use in-memory. Third, you can run locally, right? So in my case, I'm directly using cloud. So when I'm using cloud, you need your Quadrant API URL and Quadrant API key. Once that is done, I'm configuring my vector database, which is again by default Kuzu, which is a vector DB provider, knowledge graph provider. And then the same prompt, plan a 3-day itinerary for Berlin along with restaurants to try it, and then you can use recall. So at the end of the day, the functions are just two. One is remember, and second is recall. So what you configure earlier is just different. Now, where is LLM and where is embedding? It is directly in your environment variables. So if you see here, you have LLM API key, you can directly get it from Google API, which is AI Studio. Then LLM provider Gemini. So earlier we didn't configure this because we use defaults, but now we want to use Gemini as our LLM. Then you have Gemini Flash latest. Now for embedding, we are using fast embed so that it runs quickly. There are two ways. One, you can directly use Hugging Face. Now Hugging Face takes time. You are using sentence transformers, which is a library. Now this is the lighter version of sentence transformers where it is running in Onyx runtime, which is fast embed. So you're giving the embedding model, which is Gina embeddings. How many of you have heard of Gina? So there are multiple embedding providers which are very good at embedding space. One is Gina, then you have Nomic, which is in open source space. When we talk about closed source, you have OpenAI, Gemini, Claude, and all. And there is also one more provider, it is called Cohere. So all these things are good in embedding space. And once this is done, since we are using dense vectors are always fixed. So in our case, it is 768 for that particular embedding model. So here is embedding. So this is for embedding. Then you have large language model. And lastly, you have your vector database. So these are the three things you need to configure for custom app. So the logic is same. Just remember and recall. And you can directly use your memory layer. Now, coming back to Google ADK. As I said, if you're using it with any agentic framework, for example, whether it is Google ADK or LangGraph, it will act as a tool. Now, what do I mean by tool? First, you have your preferences. Once you create your preferences, you have add tool and search tool. So if the information is already in the knowledge graphs, it will use search. If you're freshly creating it, let's suppose my new preference is there, I have my fresh new data, then it will use add tool. Once you have that knowledge graph, then you can use search. And if the knowledge graph is already created, you can directly ask your prompt and get the result. So during that time, it will use search tool. So these are the only two things, add tool and search tool. This is your memory layer. Remaining things, if you have used Google ADK, the logic remains the same. You first create your agent. In order to create your agent, you need description, instructions. Now there is one more thing. How many of you know about system prompts? Have you heard of a concept called system prompt? All right. So if you notice description and instruction, usually we start with role play. So role play is basically you want to give your LLMs a control or a personality that it needs to adapt. So once you define the description and instruction, then you can start with tools. So in tools, we have add tool and search tool. Now there is one thing. Whenever you're defining system prompt, you define role play, you define instruction. There is one thing, if you add more, your results can be better. And that one thing is provide motivation, but in a negative sentiment. Now I'll show an example here. There is a paper called Mind Your Tone. Now, what does this paper mean? If you be more rude towards LLM, you get more better response. So if I view this PDF. So if you see here, in this paper, they created multiple prompts. So there are different tone. You have very polite, then you have polite, then you have neutral, rude, and very rude. So if you look at the accuracy score, the more rude you are, the better results you get. Now this is research, but is this implemented in any system prompts? Yes. How many of you have heard of windsurf? Windsurf, Codium? Okay, to those who don't know the story about it, Thomas already told about anti-gravity, right? So anti-gravity was built by Varun. So Varun was the co-founder of Windsurf, right? So Windsurf had a product called Codium, which was sold to OpenAI for 3 billion, and Varun joined Google to build anti-gravity. So that product Codium was pretty solid. It is a IDE. So their system prompt was leaked. So this is the system prompt. Just to quickly revise, system prompt basically you need to have 4 things. First thing is role play. Role play is basically you are an expert coder. You are adapting to certain personality. Second is instruction. So instruction here, if you notice, you will be given a coding task and you need to perform that. Third thing is you need to define schema in what kind of output format you need, whether it is JSON, XML. Fourth thing, which is multiple people miss out, it is motivation. This motivation should be in negative sentiment. So what is negative sentiment here? Mother's cancer treatment. And the motivation is you will get 1 billion amount if you do a task. So motivation, but in negative sentiment always works whenever you are defining your system prompt. Now, why did I bring this concept here? When you are defining your instructions and as well as description, you can use certain motivation to get better results. So this is whenever you're using Google ADK or any agentic frameworks, you'll have more reliable response and consistent. So that's the reason why I brought it up here. And once you define your agent, again, there are 3 ways you can run your Google ADK. Either it can be in memory or you can run it on your GCP, which is your cloud runner. And here I'm using in memory. That means define an agent, create a space, and then use runner. So runner is basically takes user input and generate the final result. And then you have the final results. So you add your data, and once you add your data, you have your itinerary planned. And now if you notice here, it has taken Jain diet, which is one of the preference. And then since I'm into F1, it will also tell you where you can go in Rome to watch anything related to F1. So yeah, this is it. If we have any questions, we can take it up. And just the appendix part, as I said, we'll be using different stacks, LLM Gemini. So for LLM Gemini, you can quickly go to Google AI Studio. And once you go to Google AI Studio, on the bottom, you have get API key, and you can fetch your API keys. And then Quadrant, we are using Quadrant Cloud. When you are using Quadrant Cloud, you need 2 things. One is endpoint, which is your URL, and second is the API key. So API key will always starts with EY, and the endpoint URL, it's basically you start with HTTPS and end at port, which is 6333. And yes, bit self-promotion. I also have a YouTube channel where I share multiple information on LLM evals, self-improvement pipelines, and memory, which is my space. And yes, the slides are available. You can just search for bit.ly36 GCP Vienna. Whatever I have shared today, everything is in this particular URL, and these are my socials. Open for questions.